Thank you, Bryan.
So I appreciate everybody coming out. I know it's 4:30. Everybody's probably pretty done. And my voice is about done, you guys. So, excuse me. So, exactly. Can everybody hear me okay? Come closer to the mic.
There you go. Yes.
Perfect. So, anyway, what I wanted to discuss today, we at TriStar, so I run services for TriStar. I've been with TriStar for roughly 15 years. Before that, I worked for BTC. I was out in the industry for a while. And, one of the things that's very near and dear to our hearts is the data model. So how many people here are using Windchill? How many people are using it for real full PLM, parts, change, doc management? How many people are starting to use it for PLM? Okay. So this is a really good presentation for everybody. So it's interesting because I think a lot of folks, as they go into Windchill, they don't really do a good job building their data model out. And they get into Windchill and they start seeing problems manifest and they don't understand where those problems are coming from, okay? And so that's really what this presentation is about. And so we have a number of folks on our team that have come from industry. And so some of the examples you'll see are specifically from their companies that they've worked at. So, and we're gonna build a nice deck around this, which I'll provide to you guys that will show a bunch of different examples, okay? And it'll show you what the stuff to look out for. Right. So when you look at it, we're going to discuss real briefly what a data model is. So I'm sure everybody has an idea of what that is, but we're going to give you kind of what our definition of a data model is. And it goes much deeper than what I'm going to show you. And then the havoc that a bad data model can cause in change management. Whether you're doing change inside Windchill yet or not, it doesn't matter. This can wreak havoc in even a manual paper-based change process. And then, what is a good data model, and how do you get to a good data model? Okay, so we're going to go through a little bit of that. And this is a complicated topic for 15 minutes of discussion. So I'm going to go through some of this. Some of you guys have been living this for years, probably. So just bear with me a bit. I'm going to go through some slides pretty quickly, okay? And then we'll open it up for Q&A at the end. Okay. So when you look at a data model. So depending on the systems that you're going into, we're talking about an enterprise data model. And an enterprise data model, depending on the systems, can get very complex very quickly. And so when you look at a system like Windchill, you're not looking at a flat data model. And there are many, like Wikipedia and different things out there will tell you a flat data model, like an ERP data model, isn't really a data model, okay, right? So a data model really is more oriented towards something that's an object-oriented database. It gets really complicated, really fast. And then you start modeling objects inside Windchill and it gets really complicated, right? Because you have subtypes and you got all this, links and all this kind of stuff, right? So data models can be very, very difficult. And then you start migrating data into Windchill, right? You have to map these data models properly. And so we do a lot of that at TriStar and we know how complex that is for folks, okay? And so when you look at just a simple data model, okay, and I know this is very simplistic, but I at least wanted to give folks an idea, right? You're really looking at two different types of data. You're looking at governing data, and you're looking at informative data, non-governing data, okay? And you can, if you try and keep it this simple, if you try and make it way more complex than this, your data model will get out of control. So keep it simple, first of all. Your data model should try to be simple. Now, each of these objects can be complex in their own right. But when you're looking at documents, you need to keep it this simple, okay? That's the first set of advice. And so these kind of governing pieces of data are objects, and requirements are a tough one because they kind of fit into both. But really, when you look at it, is it going to do design intent? The requirement doesn't really do that, okay? So is it informative? So it depends on how you kind of lump this in there, okay? And so when you look at havoc that a bad data model can cause, okay? And so there's a number of things, and there's a number of items that I have on here, but I wanted to put the main one up there. So when you look at all these different factors, right? So we'll tell you any type of charted drawings or charted specifications, okay? So if you have a family table, it's a bad data model, okay? Who has family tables? Everybody raise your hands because they know you do, okay? And So if you had charted specifications, so if you refer to a color document that has multiple colors in it, that's a charted specification. That's bad data model, okay? Now, I'm not saying you can't do it in Windchill. And Windchill doesn't, says it supports family tables as a best practice. No. Okay? So a lot of these things is your drawing centric, and that's what we're showing with this drawing. And this drawing is showing there's specifications on it. But you may actually have a specifications document that refers to the material. Okay? So all of these are not best practice, right? So then you start getting into using parts, and you define your parts improperly, and you have a reference document as a describing document. That's a problem as well, right? And the way those links update through change management. Or you'll put attributes on your WT part like cost or supplier. Again, it causes havoc in change management. Sometimes it's actually hard to understand it's the root cause of the problem, okay? And so when you look at all the downstream effects that these can cause, right? This unnecessary revisioning, lack of automation, there's more time spent in the ECN, the ECR, right? There's scrap, there's tribal knowledge, all these things that can be downstream effects, okay? And what's hard is you won't know the root cause, and so you continually see these things, okay? So we're gonna give you a couple examples of that. So say you have a material spec, okay? And this material spec is consumed on a drawing as a node. These are not links together. So you folks that are doing CAD data management, right, this document's living in the Windows file system. And your CAD file's sitting inside Windchill. And you're thinking, the drawing is the best place to put all of this stuff. So the drawing gets more and more stuff on it, okay? So the problem here is that you could have a performance spec as well. That might get consumed in a node, okay? These two, material and performance, actually might be related to each other. It's really hard to tell in the node that they're related to each other, okay? And so now what happens is you say, for example, you wanted to take the material and say it has talc in it, and you wanted to reduce the talc, and it still meets the performance spec. So now you're saying, you know what? I've got a good data model. I see both of these, right? And now I can reduce the cost of this part, okay? All seems good. Now the problem is you got other parts, drawings, that also have this material spec, okay? But they actually might have different performance specs, right? So you're thinking, well, that material spec, I changed all these other parts, like, good, we're reducing costs in all of these. The problem now is this performance spec is linked to both of those. Now you've changed the material, okay? And now you're starting to see defects and warranty issues and stuff like that with these other two parts. And now there's all this work that's gone back to say, what's the root cause of all of these defects? And it's a simple problem of not having data related together properly. It's a bad data model, okay? And so now you've just negated all the cost savings you tried to create by reducing the material. And we see this all the time. And so there's many of these scenarios that can cause these types of effects. And so you'll see us say that there's four main pillars of doing good data modeling, okay? So all of these will cause problems. How quickly you see those problems, it's tough to know. It's tough to tell you. Will you find the root cause of this? It depends on how much effort you put into it, okay? And so a good data model is more of a model that looks like this, okay? We spent a lot of time at TriStar coming up with this data model. It gets way more extensive than this. This is a very simplified version of it. But you can start to see that this WT part now has specific governing and non-governing and derivative data. But these material specs, for example, that ASTM spec is never linked directly to the WT part. It cannot be. The ASTM or ASME is a tabled specification. You cannot link it directly to a WT part. If it changes, per configuration CM2, you should be revising your part. That's an unnecessary revision, okay? And so, what data you relate, right? This is a very simplified version. There's way more data than this, okay? And so the other problem that we see is folks don't model this up front. They put data in windshield, and then they start doing changes. They don't understand the impact of the changes and how it should be controlled. So this table, again, is very simplified, but it gives you an idea. Every document you put in the system, you should understand exactly what it's doing when it's changed and how it impacts the part it's related to. Okay? So to get to a good data model, you have to do these, we would call 4 pillars. So a lot of folks are going from drawing-centric to try and be part-centric, right, inside windshield. Okay? We would put something above part-centric, where you attribute it like this: purposely driven, dynamically associative, automated governance. It's more than part-centric, okay? But these 4 things will get you there. Make sense? Okay? And so to get there, you may have to do data cleansing, right? This is painful, but it's absolutely necessary. Okay? And you may do a data cleansing as you go. It may not be a bulk data cleanse, but there's a process to cleanse the data. Okay? And we will tell you that you cannot do a data modeling, enterprise data modeling, and change management separate. You cannot do that. You will not optimize both of those that need to work together. Okay? And so we would advocate that we come in and help you guys do your Kaizen event, because we know what we can automate. You guys don't know what windshield can be done in windshield, so it's hard to say what's the optimal process. Okay? And so we'll tell you those both have to be done in the same event with the whole team that's responsible for it. Because your data model is not engineering, it's everybody. Okay? So that's the end. Wow, so, any questions? Without a beer in my hand, but any questions?